Well, let's speak of another variable, heart rate. If I place people under some sort of stress, make them make a request that they don't feel comfortable making, that might make their heart rate spike up to 96. And on the other hand, if for those that are in the control group that don't have to do any noxious things, that would may make their mean heart rate remain at 72. Now, what's depicted in this graph is a mean. So there might be 10 participants that contribute to the mean, or 20 or 50 or who knows what. I once participated in an experiment where we had to make an uncomfortable request of someone to do something that they didn't want to do, which was wash a sink full of dishes. And when that person forcefully declined to do what we asked them to do, they measured the heart rate of people that got declined. I was wearing a portable heart rate cuff that showed that these simple transactions can really result in a central nervous system spike. So, of course, everybody varies in their heart rate, and if you ever Google it, of course, it's hard to pin down what the mean heart rate is. What they say is the mean resting heart rate is between 60 and 100, which is not very helpful, is it? Now, speaking of contributing to that mean, if I have mean heart rates like 96 and 72, I might have some numbers that contribute to that mean, right? So here are the individual data points that collectively comprise a data set. Now, each one of these heart rates would be known as a datum or a datum, but that word is seldom used. A raw score is more likely to be used. But data are the plural of that. When I have many datums, if you will, then data are the plural of that. So I may have 5 contributors to comprise that mean of 96, as you can see. And if those 5 people in that condition that had to do something moderately stressful, you can see that one had a rather high heart rate and one was very, very low. So there was tremendous amount of variability there, but those individual data points contributed to that mean. Of course, we would just add those up and divide by 5. So a parameter is a value, usually a numerical value that describes a population. And most often that's denoted with a Greek character like mu. There's the letter mu there in bold. It looks like a U. And then the lowercase sigma, in this case, indicates the standard deviation. They're in bold and black. So, not for nothing, just by way of trivia, the mean IQ score in the population is 100, and the mean standard deviation is 15. A sample is represented by a statistic. And this is where it gets a little muddy from what we discussed before. Statistics can mean procedures by which we summarize data, as we described before. It's also the plural of numbers that describe samples. An individual statistic is a value, usually a numerical value, that describes a sample. So it's derived from measurements of the individuals in a sample. So I may have the overall population mean of IQ scores being 115, and then I may take a sample of 10 people, and theirs is a little bit higher for some reason. They have a mean of 102.3 and a standard deviation of 11.4. And by the way, our textbook uses capital M. A lot of books use X bar for the sample mean, for what it's worth. And then here's lowercase s for the standard deviation for a sample. So we'll come across these 1,000 times. And also I'm very faithful about representing populations in black and samples in red, bolded black, bolded red. Descriptive statistics. Let's now that we've defined the idea of a statistic, let's talk about what we mean by descriptive statistics that describe things. Let's take an interesting experiment. And I think this is very relevant to the way we are facing education today. When I was a visiting professor in Iowa 15 years ago, was it 14? No, it was 15. It was in the 05-06 school year back in Decorah, Iowa at Luther College. I remember the faculty back then saying, we are on the precipice of there being no more books. Everybody's going to have a Kindle equivalent, and I think Kindles had just essentially been invented then, but then you could have 50 books on a Kindle, and the Kindle weighs, 1.5 pounds, and why would anybody ever buy a book again? And the fullness of time, it's proved that that's not happened. So it might beg a question in this hypothetical experiment. How do people perform when they're reading from printed pages versus when they're reading from a computer screen? And I've got a hypothetical experiment here, as you can see, with 15 data points in each experiment. Now, there would be 30 total people in the experiment itself. One group of 15 read from printed pages, one group of 15 read from the computer screen, and you can see their averages are different. It looks to be the case that when these people took a test of some sort after having read from printed pages or a computer screen, that their average score is 26 versus 22. So one story I might tell with some caution is that it appears to be that there's some benefit from reading from a printed page. Who knows? Now, of course, I'd have to be very cautious about that. And that also begs the question of, would we arrive at statistical significance? We'll talk about that here in a few minutes.